Hello, everyone. I know that we are all very probably tired. Our brain is very overstimulated now. We are almost done. Please keep up with me. Almost the end. So I'm Céline Spriet. I'm a PhD student under the supervision of Liuba, Papeo, and Jean-Rémy Hochmann at the Institute of Cognitive Sciences, Marc Genreau in Lyon, France. And I'm very glad to talk today about the acceleration of visual object categorization throughout development. So the process of categorization is really to group alike objects together, separating them from different objects, right? And so when we talk about visual categorization, those features on which we base the categories are the visual features. And so when we see an array of objects like that, with a lot of objects, we actually quite automatically categorize them, and here especially into two big categories that are the animate and the inanimate categories. And this is a category that is found quite early on in life, spontaneously. So that we have found previously that 4-month-old infants are already able to represent those two categories, animate and inanimate, spontaneously in their behavior. So that when we show to them two images from different or same categories, they would actually represent them as being part of animate or inanimate categories. This is what we see here with this matrix of dissimilarity that represents infants' judgment toward the two categories. In red, you have high similarity, and in blue is represented a low similarity according to infants' judgments. And so we clearly see here, somewhere, no. We clearly see a red square within the animate comparison, a red square within the inanimate comparison, and the blue squares between animate and inanimate comparison, so that we will clearly see animate and inanimate representation as soon as 4 months of age. Interestingly now, as infants get older, they actually represent more and more spontaneously in their behavior categories and finer-grained categories. And this made us think that they actually, for doing that, integrate more and more visual features together, so that the more visual features you are able to integrate, the finer the representation of the objects, and so the better the categorization. Now, those features, we know from the literature, are encoded into the ventral stream, right, in adults. And in the ventral stream, we would have hierarchical temporal hierarchy, so that in the features that are encoded in the most posterior areas of the ventral stream would be the one that would decay the fastest, while the ones that are encoded in more anterior region of the ventral stream are the ones that decay the slowest. So that if we represent the activation of 3 different features across time, here we would have the feature C in yellow that would actually be encoded in most anterior region. Now, in parallel of those results, we actually see also from the literature that there is a huge acceleration of information processing throughout development. And especially here is represented the timing of visual attentional capacities of 5- and 8-month-old infants, 3-year-old children, and adults. And you clearly see this huge acceleration of the timing of information processing. And so this made us think about a theoretical model where if we take back our activation of the 3 different features across time, now we add an information about the integration of the timing. Imagine that the system is integrated the features quite lately in time, then it will have access to only fewer features, those ones that decay the slowest. Imagine now that it experiences an acceleration of the integration. Now it will have access to more and more features. And so maybe to a better representation of the objects. And so we thought that this model could actually account for our behavioral results. Now this is a model that we would like to ultimately test. We will not exactly test that today. We will first ask whether we see a direct link between the speed of images presentation and the visual categorization capacities, as the first question. And so to do so, we first tackled this question in human adults using the frequency tagging paradigm that we already see today. So this is an example with a 6 Hz presentation. The principle of frequency tagging paradigm is simply to show the images to a participant at a certain frequency rate, called the base rate. Here it's 6 images per second, so 6 Hz presentation. And within this stream of images, we can show a second frequent apparition of the images, that is the categorical apparition of the images. So you see here that we mainly have inanimate object categories, and every 5 images we have an animate instances that is appearing. We did that with different timing of presentation of the images. We did that with 6 Hz presentation, 12 Hz presentation, and 30 Hz presentation. Now, simply because the participants are looking to the streams of images, as we already know now, we would have a synchronization of their brain activation towards the frequency of the presentation of the images. And so this is what we see here with the 6 Hz presentation, 12 Hz presentation, and 30 Hz presentation. And what is nice also is that if the brain is automatically categorizing the images, so reacting about the same way for all animate, about the same way for all inanimate, but differently between both categories, we would see a second synchronization of the brain activity towards the categorical stimulation. And so this is what we see here with the 1.2 Hz peak. And we actually see different peaks because the response of the brain is not a pure sinusoidal, it's a more complex response. And so we have what is called harmonics, simply, of the response. What I will show you is something called the baseline corrected amplitude. So it's the amplitude at the frequency of interest, to which we subtracted the average amplitude surrounding this amplitude. And we actually sum those baseline, and this is the results. And so for the results here, the 6 Hz, for the 6 Hz presentation, so we see the sum of baseline corrected amplitudes centered around the categorical response. We see here the distribution of the response across the group, and we see here the distribution of the response across the scalp. This is 6 Hz presentation, 12 Hz presentation, and 30 Hz presentation. And so what we clearly see here is that in every stimulation, we have a clear categorical response. We already have a sense that actually the timing of the presentation of the images is impacted the categorical response, right? And so this is what we see here, where we see that the categorical response with the 30 Hz presentation is actually smaller than the categorical response measured with the 6 Hz and 12 Hz presentation. And so here we concluded that the speed of images presentation does impact the adult's capacity to make sense of what they see. And by making sense of what they see, we mean that they are able to categorize the images. Now this is in adults, but of course I think we are all interested into developmental questions, so let's move on towards infants results. We tested 4 and 9-month-old infants, showing them the same type of trials as adults did, a little bit slower, but this is still fast for them. We show them 4 Hz, 6 Hz, and 12 Hz presentation. Now for the results, this is the 9-month-old infants' results. We have shown to them 6 Hz presentation and 12 Hz presentation. And you can see that for both presentation, even with the 12 Hz presentation, we are able to capture their categorical response. Now this is for the 4-month-old infants. And here we have shown them the 4 Hz presentation and the 6 Hz presentation. And you can see that if we are able to capture the categorical response at 4 Hz, we failed to do so with 6 Hz presentation, so the fastest presentation for them. So altogether, we clearly see a categorical response in every infant. we see that this response is diminished with the time of the presentation of the images. And we see here especially that at 6 Hz presentation, we have a higher categorical response in 9-month-old infants compared to 4-month-old infants. So we also see a higher categorical capacities with development. Here I also want to highlight that qualitatively at least, we see that the categorical response at 4 Hz in 4-month-old infants is quite equivalent to what we are able to capture with the 12 Hz presentation in 9-month-old infants. But so anyway, here we can say that the speed of images presentation does also impact the infant's capacity to make sense of what they see, and that this capacity gets faster with development. So to wrap up together, the faster the presentation, the lower the categorical response. And again, we see that in 4-month-old infants with the 4 Hz presentation, the categorical response is quite equivalent to the one captured with the 12 Hz presentation in 9-month-old infants. And so 9-month-old infants show the categorical response at a frequency rate that is at least 3 times faster than 4-month-old infants. And so when a 4-month-old infant is able to make sense of this type of trials, a 9-month-old infant is able to do so with this type of trials, and adults are able to do so with this type of trials. So with that, I would like to end by saying that being faster in processing visual information might help us to integrate more and more visual features, hence representing more and more visual categories. So this is coming back to our theoretical model that we would like to test ultimately. And we could think that might be very detrimental for a system to not be able to integrate the categories at a fast timing. But actually it might also be beneficial. Because if we think about the system that is facing this blooming, buzzing world, basically, with all those visual information that we have to see every day, and we have to learn about that, then maybe it's easier for us to kind of protect ourselves and being able to only integrate those features that are very stable throughout time. And so then we can learn about them and learn about more and more features in time. In the end, the acceleration helps us to understand the world throughout development. And I would like to thank my collaborators and you for your attention.
Thank you, Céline, for the amazing talk. And we have a lot of time for questions.
Thank you very much. A clarification question. I was wondering what this lower activation means in the case of the category response, right? Because the categorical response should be categorical. Either you have the category or you don't. What does it mean to have it more or to have it better? Or how should we think about this?
Yeah, I think we could try to see that throughout time. And I'm not sure, I don't know exactly what it means. But I think maybe we have an easier capacity to categorize, and so that when the images are presented more slowly, so that every time we see the images, we really have those full activation that comes into our brain. But when it's faster, the system is really like overloaded, and so we really pin towards more specific activation, basically. Don't know if that makes sense. So basically, what would be the difference between the fast and the slow presentation would be the kind of amount of activation of the brain. Yeah, don't know if that makes sense.
Just a small comment, but if the small activation of the brain is enough for category representation, why do we want more, or why does it make sense to have more? That was the question.
then it depends on which brain areas are recruited by the presentation of the images, right? So if slow presentation allows you to recruit more brain areas, then you would have a more stronger activation. But if you are, how do you say that, overstimulating the brain, then you would have maybe less brain areas that are activated, and so then you would have a smaller response. But in any case, you have the response when the category are represented. Yeah. It's just the difference that.
Any more questions? Yeah, in the back.
Thank you for the talk. I was wondering if you did it also with the face stimuli, or whether that could enhance categorization because it's more social.
Yeah, so I know that other teams are looking for face categorization, especially human face categorization. We did not do that. We simply looked to animate in animate because this is one of the first that we have found in our samples. Human face, especially categories, might be very specific. So I would say that, yeah, we clearly might be able to capture something very different here with human face categories. And I know that they are able to capture that with 6 Hz presentation, for instance, so faster. Yeah, but that's something that we think about.
Thank you.
We still have time.
In your experiments, the stimuli were complete objects, if you wish. But in many everyday cases, you don't really have visual access to the entire object. Do you think your paradigm would work with partial objects or like semi-occluded objects or stuff like that?
Probably. Probably because the visual features are still here in a way. But yeah, that's something to dig in, maybe. But I would say that I would personally think that it will work. Yeah. Thank you.
Hello. Thank you for the beautiful talk. So in the study that you presented, there was something where there was a baseline stream of images, and once every 5 images have something special in that they are animate. You presented the background in terms of the category animate versus inanimate, which is a symmetrical conception of the category. Do you think you would have the same results if you had a stream of animates and here and there an inanimate picture?
So that was just for the sake of presentation, but we did both. And so far we did not find any difference between presenting an animate within inanimate or inanimate within animate. Yeah.
Okay, our time is up. Let's thank Céline again.